Imagine this. You are sitting at your desk. It's about 3:45 p.m. on a Friday afternoon.
Oh, yeah. The absolute worst time of the week.
Right. The office is starting to quiet down, but you are just staring at a monitor that is a total chaotic mess of open browser tabs.
And the cursor.
Yes, the cursor in your main document is just blinking at you. It's almost mocking you, honestly.
Because you know what you still have to do.
Exactly. You have this mountain of meeting notes to summarize from like 3 completely different vendor calls, and a competitor pricing analysis that your boss just casually mentioned needs to be drafted by end of day.
Casual end-of-day Friday requests are the enemy of joy.
They really are. And then on your second monitor, there's this massive, unwieldy spreadsheet.
Let me guess. The formatting is totally broken.
Oh, completely. The date formats are all mismatched. The VLOOKUPs are throwing errors everywhere. It's going to take hours of manual, mind-numbing formatting before you can even begin to pull a single coherent insight out of it.
It's that universal sinking feeling of modern knowledge work, that Friday afternoon dread.
It really is. It's that repetitive manual grind, the kind of tedious copy-pasting work that makes you lean back in your chair, rub your eyes, and just think, I really, really wish I had a personal assistant.
Because you weren't hired to format dates in Excel.
No, you were hired for your brain. You were hired to build strategy. But somehow you end up spending, like 60% of your week just wrangling messy data and formatting text.
And that disconnect, that gap between the strategic work you want to be doing and the robotic work you're basically forced to do, that is the defining problem of the modern corporate environment.
Which is exactly why we are here today. Welcome to a special Cortex Lab deep dive.
A very special one.
Yeah, we have custom tailored this deep dive specifically for the learner, for you. Because if you're listening to this, you are someone who wants to cut through all the relentless, breathless tech jargon out there.
There is so much jargon, it's exhausting.
It's totally exhausting. You just want to figure out how to actually make AI work for you in your real life at your actual desk to solve that exact Friday afternoon nightmare we just talked about.
Right. We aren't talking about theoretical AI today. We aren't talking about science fiction or, what might happen 10 years from now.
No.
We're talking about practical, applied, everyday leverage that you can use the second this audio finishes.
Exactly. Today's source material is an incredibly revealing stack of documents. We've got internal enterprise blueprints, AI strategy roadmaps, and detailed prompting guides straight from the biggest players in the space.
Companies like Google, OpenAI, McKinsey, the heavy hitters.
The absolute heavy hitters.
Yeah.
We're looking at how the most successful, high-performing organizations in the world are currently deploying this technology to their actual workforces.
And we have a very specific mission for this deep dive.
We do. Our mission is to extract 5 key foundational lessons from these sources. We're going to use real-world stories to help you turn AI from a novelty chatbot that you play with for 5 minutes into a customized, relentless super assistant.
Yeah, it's the difference between treating AI like a parlor trick that writes a funny poem about your dog.
Oh, which is fun, but not very useful at work.
Right. And understanding it is a fundamental shift in how you operate as a professional.
Okay, so let's unpack this, because to solve that Friday afternoon scenario, we have to start by acknowledging that the technology itself is undergoing a massive evolution right now.
A huge evolution.
We really cannot just talk about basic chatbots anymore.
No, we can't. If you want to reclaim your time, you first have to understand this foundational shift happening right beneath the surface of these platforms.
Lesson 1?
Exactly. Lesson 1. We are moving away from simple reactive chatbots, and we are moving toward what the industry calls autonomous agents.
Autonomous agents. I gotta admit, whenever I read that phrase in the sources, it sounds very, James Bond.
It does sound like a spy movie.
It really does. But what does that actually mean in plain English for someone just sitting at a desk?
It's a critical distinction to make, honestly, because it completely changes how you interact with the software.
Okay, lay it on me.
So a basic large language model, an LLM chatbot, which is what most people are used to, is essentially reactive. You type a prompt, it spits out an answer, and then it entirely stops.
It goes to sleep.
Right, it goes completely dormant. It has no agency. It literally just waits for you to explicitly tell it what to do next.
Okay, and an agent.
An AI agent, on the other hand, is a system designed to independently accomplish multi-step tasks on your behalf.
Independently, that's the key word.
Yes, it leverages the underlying language model as its reasoning engine to manage a workflow. And crucially, it makes decisions on its own until a specific goal is met.
So it doesn't just stop after step 1. It loops.
Exactly. It operates on this continuous loop of observation, reasoning, and action.
Can you give an example of that? The blueprints had a really good one, I remember.
Yeah, to really visualize this, think about the payment fraud analysis analogy that was highlighted in the enterprise blueprints. It's a brilliant way to understand the shift.
Oh, right, the credit card fraud thing.
Yep. So for decades, the financial industry has used traditional rules-based software to catch credit card fraud. That old software is basically like a rigid recipe book.
Meaning it only follows exact instructions.
Right. It only flags a transaction if very specific, hard-coded criteria are met.
Like, if the purchase is over $1,000 and the IP address is in a foreign country, trigger a fraud alert.
Precisely. But a problem with the rigid recipe book is that fraudsters are incredibly smart.
They figure out the rules.
Exactly. They learn the rules of the system, and they exploit the gray areas. They engage in what's called structuring. So if the alert triggers at $1,000, what do?
They buy something for $999.
Exactly. And the old software just lets it right through because technically rule number one wasn't broken.
Wow. So the rules-based engine breaks down because it has absolutely no judgment?
None. It cannot infer intent. An AI agent, however, is described in our sources as a seasoned investigator.
I love that phrase. Seasoned investigator.
It really fits. Because an agent doesn't just blindly check boxes on a list. It looks at the subtle, holistic context of the situation. It evaluates behavioral patterns.
So it's asking broader questions.
Right. The agent asks itself, does this transaction make sense given this specific user's entire 5-year purchase history?
Ah, okay.
Does it make sense given the time of day, the velocity of the transactions, the type of merchant, and the device they're using?
So it's solving the mystery using nuanced reasoning, even when clear-cut rules aren't explicitly violated.
Exactly. It thinks about the whole picture.
That is a fascinating way to frame it. The software is no longer just a calculator spitting out true or false. It's an investigator making judgment calls. But I want to pause and dig into the mechanics here. Because it's easy to say, it acts like an investigator, but how does it actually do that?
Mechanically speaking.
Yeah, how do you build a piece of software that investigates?
Well, the blueprints break down the anatomy of an agent into what they call the triad. 3 simple core components that work together.
Okay, the triad. What's number 1?
First, you have the model. This is the brain, the reasoning engine itself, so like GPT-4o or Gemini or Claude.
Makes sense. Number 2.
Second, you have the tools. These are the hands of the agent.
The hands.
And third, you have the instructions. These are the rules and the behavioral logic that define exactly how the agent should behave.
Okay, let's hover on that second part for a second. The tools. Because an AI is just code on a server. It doesn't have literal hands.
Right, no physical hands.
So when you say it uses tools, what are we mechanically talking about?
We are talking about APIs, application programming interfaces.
Okay, can we break that down? Because I hear API thrown around in every single tech meeting I've ever been in. But if I'm not a software developer, what does an API actually do in this context?
Okay, think of an API as a digital waiter in a restaurant.
A waiter?
Yeah. You, the customer, are sitting at the table. You know exactly what you want. Let's say you want a burger.
Sounds good right now, actually.
Right. But you can't just walk into the kitchen, push the chef aside, and start cooking the burger yourself.
Obviously not. You aren't allowed back there.
Exactly. You need a standard, agreed-upon way to tell the kitchen what you want, and a way for the kitchen to bring the result back to you.
So the waiter takes your order.
The waiter takes your order, translates it to the kitchen in a format they understand, and brings the food back. An API does exactly that for software. It's a standardized language that allows 2 completely different programs to talk to each other securely.
Okay, so how does the AI model use the waiter?
This is where the magic really happens. The underlying model is trained to recognize when it needs outside help to solve a problem.
Give me an example.
So if you ask an agent to check the current weather in London, the model knows its internal training data is frozen in the past. It knows it can't just guess the weather.
Right, it doesn't actually know if it's raining right now.
Exactly. So instead of generating a guess in English text for you, it literally writes a tiny, perfectly formatted string of code, usually in a format called JSON.
Okay.
And it hands that code to a weather API. It essentially hands an order to the waiter.
And the waiter runs to the kitchen.
The waiter runs to the weather service, gets the current temperature, and hands it back to the AI.
Oh, wow.
And then the AI reads that raw data and translates it back into a natural English sentence for you.
That is incredibly clear. So instead of me asking a chatbot a trivia question, An agent is basically like me giving a really smart, eager intern a company credit card and a highly specific goal.
That is a perfect analogy.
I'm basically saying, here is your brain, here are your tools, like the ability to search the web or access my calendar. Now go figure out how to book this specific flight and hotel within a $1,000 budget, and don't come back and bother me until it's done.
That intern analogy is exactly right.
Yeah.
And if we connect this to the bigger picture of the modern workforce, that is exactly why this technology is experiencing such explosive, unprecedented growth in enterprise setting.
Because everyone wants an intern.
Everyone wants an intern. But the truly revolutionary part isn't just that the intern exists. It's that you do not need to be a software engineer to hire and manage this intern.
That's the crazy part.
It is. Non-coders are suddenly able to build these custom autonomous agents using just natural language. You don't have to write Python or C++ to build an agent.
You just write instructions in English.
Exactly. You are just talking to the intern,
Yeah.
telling them what tools they have access to and what their ultimate goal is.
Which is incredibly empowering for the average worker, but I mean, it also introduces a massive new problem.
What's that?
Well, if I am suddenly a manager of digital interns, managing them requires knowing how to effectively communicate with them.
Yes.
If I give a human intern terrible, vague instructions, I am going to get terrible, confusing results back.
And they will probably take 3 days to do it wrong.
Exactly. And the exact same principle applies to AI. The output is entirely dependent on the quality of the input.
Which naturally brings us to the second major theme we extracted from the sources.
Yeah.
Lesson 2, the art of the prompt.
Yes, the prompt. And the sources have some truly wild data on how bad we currently are at this.
We are so bad at it.
There's this staggering statistic from the Google Workspace prompting guide that we reviewed. They analyzed how average corporate employees interact with AI, and they found that when people get frustrated and claim, the AI is stupid or it doesn't work,
Which happens all the time.
they found it is almost always because their initial prompts, the instructions that they give the AI, are less than 9 words long.
Less than 9 words.
Yeah.
If things like, write an email to my boss,
Or summarize this PDF document.
or make this sound professional.
Exactly. And when you think about it, it makes total psychological sense why we do this.
Why is that?
Because we have been conditioned by over 2 decades of using Google search to type in broken caveman phrases.
Oh, right. We type weather New York, or best pizza near me, or fix broken sink. We don't use verbs, we don't use context, we just throw keywords at a search bar.
And we bring that exact same ingrained habit to a conversational AI.
Yes. And the AI fails because it doesn't have the context it needs to reason.
We treat a reasoning engine like a search index. It is a fundamental mismatch of the tool.
But the data in the Google Guide shows the flip side, too. They found that the most fruitful prompts, the ones that yield high-quality, immediately usable results that actually save people time average exactly 21 words.
21 words. That jump from 9 words to 21 words is the inflection point.
It really is. It is the difference between treating the AI like a frustrating toy and using it as a massive productivity multiplier. And to be clear, we aren't just talking about adding filler words to hit a word count.
Oh, no. We are talking about adding structural context.
Right. And to help people build that structure, the Google Guide breaks it down into what they call the 4 pillars of a perfect prompt.
Let's walk through them because this is highly actionable for anyone listening.
Pillar 1 is persona. You have to tell the AI who it is supposed to be.
Setting the persona, why is that so crucial?
Because it changes the entire vocabulary, the tone, and the conceptual framework the model uses to generate its response. It grounds the AI.
Oh, I see.
Yeah, if you say, act as a tough, meticulous financial auditor, it will look for errors and speak formally. If you say, act as a patient, creative kindergarten teacher, it will use simple analogies and an encouraging tone.
You are giving the reasoning engine a specific lens through which to view your problem.
Exactly.
Okay, pillar 2 is the past. What exactly, mechanically, do you need it to do? Pillar 3 is context. What is the background information? Why are we doing this? Who is the audience?
And finally, pillar 4 is format. What should the actual output look like?
Like, are we asking for a bulleted list? A 3-paragraph email?
No.
A table with 3 columns?
Persona, task, context, and format.
Yeah.
If you naturally include those 4 elements in your instruction, you will effortlessly hit that 21-word sweet spot.
That makes total sense.
But out of those 4, the sources emphasize an absolute golden rule that cannot be skipped.
The most important element.
The most important element of any prompt is the action. You must always include a clear, specific verb.
Draft, analyze, compare, brainstorm, extract.
Exactly. Without a clear verb, the AI doesn't know what its primary directive is. It'll just try to, I don't know, summarize whatever you pasted in.
Okay, let's put this into practice to show the contrast. Let's go back to our Friday afternoon scenario.
The dreaded Friday scenario.
Yes. If I use the old 9-word caveman prompt, I might say, write an email to the vendor about pricing.
And the AI is going to spit out a generic robotic-sounding email that you'll have to rewrite anyway.
Right, which saves me 0 time. But if I use the 4 pillars, the 21-word version looks like this. Act as a firm procurement manager. Draft a short, bulleted email to our software vendor stating their new pricing is 20% too high.
Beautiful. You hit persona, task, context, format.
And I use the verb draft. It takes me maybe 5 extra seconds to type, but the output is actually usable right away.
It saves you 20 minutes of editing. It is front-loading the effort to guarantee the result.
But wait, here is where it gets really interesting and honestly a little confusing.
Ooh, what's confusing?
Well, as I was reading through these different enterprise roadmaps side by side, I found a fascinating contradiction that I really want you to clear up.
Okay, what's the contradiction?
Well, the Google Workspace Guide is explicitly telling us to keep our prompts concise, right around that 21-word mark. Keep it conversational, hit the 4 pillars, but be brief. But then I look over at the OpenAI Guide on building autonomous agents, and it says the exact opposite.
I see where you're going.
It says we should be building highly detailed multi-step routines. It says enterprise users are literally feeding dense 10-page policy documents into the AI to convert them into massive, numbered instruction sets for their agents.
Yep.
So which is it? Do we write 21 words or do we write a 10-page novel?
It's a great observation, and it highlights the fundamental misunderstanding people have about how this technology is deployed.
Okay, explain.
It comes down to the difference between using AI as an ad hoc daily assistant versus programming an autonomous agent. They are 2 entirely different modes of operation.
2 different modes.
Yeah. The Google Guide's 21-word rule is perfect for a quick, one-off daily task. If you are sitting in your email client and you just need to draft a quick apology to a specific customer because their shipment was delayed.
A 21-word prompt using the 4 pillars is exactly what you need.
Exactly. It's fast, it provides the immediate context, and the job is done. You are actively steering the car.
Right, I'm in the driver's seat. I just need a quick assist.
Exactly. But when you are building an autonomous agent, our digital intern, who is going to be running in the background, handling hundreds of customer service tickets on its own while you sleep.
A 21-word prompt isn't going to cut it.
That's a recipe for absolute disaster.
Why? Just because it's too vague?
Because a 21-word prompt cannot account for edge cases. When you are permanently instructing an agent that will operate without your supervision, you have to account for the what-ifs.
Like, what if the customer is demanding a refund?
What if the item they want is permanently out of stock? What if they use profanity?
I see.
The short prompt doesn't give the agent any behavioral logic for those scenarios, so the agent will just guess, and it will likely guess wrong.
Okay, so what does that dense 10-page prompt actually look like? Are people really just typing a 10-page paragraph?
No, it looks much closer to pseudocode. The agent blueprints advise converting dense policy manuals into highly structured, numbered lists of instructions, often using things like XML tags to separate the rules.
You are essentially programming the behavioral logic of a system.
Right, it looks like. Step 1, analyze user sentiment. Step 2, if sentiment is angry, execute the apology protocol and escalate to a human. Step 3, if asking for a return, check database for purchase date.
Wow, okay. Very rigid.
You need that dense, rigid format to ensure predictability and safety at scale. So, ad hoc, manual tasks get 21 words. Autonomous automated agents get the policy manual.
Okay, that clarifies it perfectly. The operational goal dictates the prompt length, but that naturally brings us to the next massive hurdle, which is lesson 3.
Lesson 3.
Let's assume you, the listener, now know how to talk to the AI. You know the 4 pillars. You know the difference between a short prompt and an agent instruction. The next logical question you're going to ask is, what do I actually ask it to do?
Yes. What do I do with it?
I have the intern, but my mind is completely blank. Where do I even start?
This is perhaps the most common failure point. The blank cursor syndrome.
The blank cursor syndrome, yes.
People get access to these incredibly powerful enterprise tools. They open the chat interface, and they just freeze. They don't actually know what their own workflows consist of.
Exactly. And to solve this, I absolutely loved this specific strategy from the sources. It's a story about Clairvaux, who is the chief product officer at LaunchDarkly.
She's brilliant.
She created this brilliant, highly practical concept that she calls the anti-to-do list.
It is such a psychologically clever way to approach automation.
It really is. Instead of sitting down and trying to invent some grand, complex AI strategy, she just looks at her own daily friction. She literally documents every single annoying, repetitive, low-value task that she actively hates doing.
Things like manually cracking competitor mentions across 10 different Slack channels.
Or collating weekly KPIs from 3 different dashboards into a single summary document for a Friday meeting. She writes them all down on her anti-to-do list, and for every single item, she asks one simple question: how can I never do this again?
And she systematically uses AI to automate them off her plate.
I love that. How can I never do this again?
What is so powerful about the anti-to-do list is that it completely shifts the cognitive burden. It shifts the mindset from an abstract question, what can AI do? Which is way too broad to answer, to a deeply personal question, what do I hate doing?
Because every single professional on Earth knows exactly what they hate doing.
Exactly. It's a much easier starting point.
Yes, but to help us systematically conquer that anti-to-do list once we write it down, the enterprise roadmaps provide a kind of cheat code, a framework. They call them the 6 use case primitives.
The primitives. If you take nothing else away from this discussion, understand these. These are the foundational building blocks of AI value.
They really are.
The sources argue that virtually every complex knowledge work task can be broken down into these 6 categories. If you understand them, you can find scalable value in any department, in any job role, immediately.
Let's run through them and explain how they actually look in the real world.
Okay, what's the first one?
The first primitive is content creation. This is the one everyone knows. Drafting emails, writing marketing copy, summarizing meeting notes, translating documents.
But look at the scale of it in the enterprise sources. It's not just writing one email.
Right.
Promega, a major life sciences company, documented saving 135 hours in just 6 months by using AI to generate the first drafts of their marketing email campaigns.
135 hours. That is nearly 3.5 weeks of full-time work just given back to the marketing team.
And what were they doing with that time previously?
They were staring at a blank page, trying to figure out the perfect subject line, doing manual A/B testing of paragraphs.
AI took the blank page phase down to 0 seconds, allowing the humans to spend their time editing and strategizing instead of drafting.
Exactly. The second primitive is research. This is having the AI digest massive amounts of unstructured data.
Right. You can upload a 100-page PDF of a new regulatory law and ask the AI, pull out the 5 specific clauses that will impact our supply chain logistics, and summarize them in bullet points.
The third primitive is coding, writing, debugging, or translating software code.
The fourth is data analysis, uploading a massive, messy spreadsheet and asking the AI to find the trends, clean the formatting, or generate a chart.
The fifth is ideation and strategy. This is using the AI as a tireless brainstorming partner, like give me 10 different contrarian angles for this product launch.
And the sixth primitive is automations. This is where we start moving toward agents stringing the other primitives together so they happen in the background automatically without you clicking anything.
Okay, but let's look closer at those middle primitives, coding and data analysis, because the case studies and the blueprints reveal something truly wild happening here.
Yes, the Tinder example.
Consider Tinder, the dating app. Their software engineers are using AI to do the coding chores.
Which is fascinating.
But what constitutes a coding chore for a top-tier engineer?
Writing things like bash scripts.
What's a bash script?
A bash script is essentially a command line script used to automate mundane operating system. Tasks like moving files around on a server or setting up a local testing environment.
Oh, okay.
Engineers notoriously hate writing them because the syntax is finicky, it's not creative, and it's just tedious busy work. It often gets deprioritized, creating a massive backlog.
Makes sense.
By using AI as a co-pilot, the Tinder engineers can just say, write a bash script that moves these logs to this folder every Tuesday, and the chore is done instantly. It clears the mental clutter.
Okay, that makes sense for actual software engineers. But here is the real aha moment for me in these sources.
What was it?
The biggest revelation isn't that software engineers are coding faster, it's that non-coders are suddenly coding.
Yes.
The blueprints are full of examples of marketing managers and finance professionals using natural language to write complex Python scripts to automate their monthly financial close, or writing advanced SQL queries to pull customer data directly from the company database.
They don't need to submit an IT ticket and wait 3 weeks for a data pull anymore. They just ask the AI to write the SQL for them.
It is the democratization of technical capability. AI acts as a universal skill bridge.
It really does.
Okay, I have to pump the brakes here.
Oh,
I need to push back on this heavily. Because this sounds great in a McKinsey slideshow, but let's talk about reality.
okay. Let's talk reality.
If you are telling me, someone who majored in communications, to just use an AI to write a complex SQL query,
Wait, I know where you're going with this.
how do I know it's right?
Yeah.
If I paste that SQL into my company's live database and the AI hallucinated a wrong table join, I could pull wildly inaccurate revenue numbers.
Yep.
I could present those wrong numbers to the board. And the terrifying part is I wouldn't even know it's wrong because I don't know how to read SQL to check its work. Isn't this incredibly dangerous?
That is exactly the right instinct.
Yep.
And it is the exact friction point that holds many companies back. But the way enterprise AI systems handle this now is brilliant.
Wow.
You are assuming that the human has to take the raw code and run it themselves. But that's not how the data analysis primitive works in modern tools.
How does it work then?
They use what is called a sandboxed environment, or advanced data
A
analysis.
sandbox.
Yeah, when you upload your messy Friday afternoon spreadsheet to an enterprise AI and say, find the revenue trend, the AI doesn't just show you the Python code and say, good luck running this.
Oh, thank goodness.
Right. The AI writes the Python code, and then it runs the code itself inside a secure, isolated digital sandbox on the server.
Okay.
If the code breaks or throws an error, the AI reads the error, debugs its own code, rewrites it, and runs it again. It does this loop instantly until it works.
So it acts as both the programmer and the compiler?
Exactly. And the final output it gives you isn't the code, it's the finished, formatted chart or the clean spreadsheet.
Oh.
Now, to address your point about logic hallucinations, what if it joined the wrong data? The key technique for non-coders is to prompt the AI to explain its logic. You ask it, generate the revenue chart, and explain to me, step by step in plain English, exactly how you calculated these numbers.
So I can check the math conceptually.
Exactly. You may not know how to read Python syntax, but you do know your business logic. If the AI says, I added Q1 and Q2, but I excluded the European region, you can instantly spot the logical error and say, no, European sales must be included. Recalculate.
Wow. Okay. That completely changes the dynamic. It allows me to verify the logic without having to understand the syntax.
Exactly. Which goes back to what you were saying about skill bottlenecks.
Precisely. In any traditional organization, work grinds to a halt when you have to wait for a specialized expert. You have an idea for a data visualization. Put in a ticket and wait 2 weeks for the analytics team.
You need an interactive web prototype for a pitch. Wait 3 weeks for the design and engineering team to have bandwidth.
These skill bottlenecks kill momentum. But if you understand those 6 primitives, you can spin up that prototype, query that database, or analyze that spreadsheet instantly using just plain English. It removes the bottleneck.
It is incredible.
Yeah.
But it still requires a massive leap of faith.
It does, which leads us perfectly into lesson 4. The obvious fear that every executive has when they hear this.
The fear of losing control.
Exactly. If we are handing over our entire anti-to-do list to an AI and empowering every employee to run advanced analytics, how do we know the system as a whole isn't going to go rogue? How do we build trust?
You cannot scale what you do not trust. And if you want to understand how to systematically build that trust, we have to look deeply at the story of Morgan Stanley from the OpenAI case studies.
Morgan Stanley, you don't get much more high stakes than global wealth management.
Exactly. It is a highly sensitive, heavily regulated, relationship-driven business. Trust is literally their entire product.
If a financial advisor gives a high net worth client bad information that was hallucinated by an internal AI,
The financial and reputational consequences are catastrophic. They could be
Yeah.
sued.
so what did they do?
So Morgan Stanley didn't just unleash AI blindly to their thousands of advisors and say, have fun. They started with a rigorous, exhaustive process called evils.
Evils. Short for evaluations, I assume. What exactly does an evil look like mechanically?
An evil is a structured, systematic process used to measure how an AI model performs against a specific human-verified benchmark.
Okay, like a test.
Think of it as a grading rubric or a massive final exam for the AI. For Morgan Stanley, they didn't just test it on a few casual questions. They built a massive data set of hundreds of deeply complex, historically accurate financial questions.
Wow.
and they had their top human expert trainers answer those questions to create the golden answers.
Humans are key.
Right. Then they fed those same hundreds of questions to the AI, and they systematically compared the AI's outputs to the golden answers.
That is rigorous.
And they weren't just grading for raw factual accuracy. They were grading for compliance, for formatting, and crucially for tone. Yes. Does this sound like a Morgan Stanley advisor, or does it sound like a generic robot? They ran these evils repeatedly, tweaking the system prompts until the AI was scoring perfectly before it was ever allowed near a real advisor.
They made it take the exam until it got an A+. And because they established that trust through rigorous evils, the adoption numbers were staggering.
Let's hear the numbers.
According to the blueprint, today, 98% of Morgan Stanley advisors use their custom AI assistant daily.
98%.
98% daily active use for a new enterprise tool is unheard of. And even more impressively, they found that advisors accessing internal knowledge documents jumped from 20% to 80%.
The AI made their own dense, buried internal intelligence infinitely more accessible, and it did it safely.
That is a massive operational win. But in building these systems, the enterprise roadmaps point out a major recurring pitfall that companies fall into when trying to set up these evils. A classic mistake that derails AI projects before they even launch.
Ah, yes, the model sizing mistake.
Yes. It is a fundamental error in resource allocation.
Right, because people try to save money right out of the gate. The logic makes sense on the surface. They look at the pricing and say, well, the biggest, smartest models, like GPT-4o or Claude 3.5 Sonnet, are expensive per query.
Right.
So let's build our prototype and run our evils using a smaller, cheaper model to save a few bucks while we experiment.
And that is entirely backward. It is the fastest way to convince yourself that AI doesn't work.
Why? If the small model is cheaper, shouldn't you try to make it work first?
Because if you start with a small, less capable model and it fails your evil, if it gets the answer wrong or hallucinates policy, you have no idea why it failed. You are flying blind.
Oh, I see.
Did your prompt lack context? Are your underlying instructions bad? Or is the small model just simply not smart enough to handle the complex reasoning required for your specific task?
You don't know.
You don't know, so you spend weeks endlessly tweaking prompts to try and force a small model to do something it physically cannot do.
It's like asking a middle schooler to take a college calculus exam. And when they fail, you blame the wording of the questions instead of recognizing they just don't know calculus.
Exactly. The golden rule from the enterprise blueprints is to establish your baseline with the absolute best, most capable, most expensive model available.
Prove that the task is theoretically possible.
Prove that your prompt structure works. Get your accuracy up to 99% on the big model.
And then you worry about the cost.
Right. Once the big model is acing the evil, then you can try swapping in a smaller, faster, cheaper model like GPT-4 Mini.
And see if it still works.
If the small model also passes the evil, fantastic. You just saved a ton of money and lowered your latency. But if it fails, you know definitively that the task requires the heavier reasoning of the larger model, and it's worth the cost to avoid hallucinations that could ruin your brand. You must establish the baseline first.
Okay, so evils ensure the AI is accurate when it's behaving normally. But what about when things go off the rails?
Like what?
What stops a customer-facing AI agent from going completely rogue? We've all seen the screenshots on Twitter of a company's customer service bot being tricked into swearing or writing poetry about how terrible the company is.
Oh, yeah. That is where guardrails come in. You do not just rely on the main AI model to behave itself. You build a layered defense mechanism around it.
Layered defense. Can you give me an analogy for how that actually works in the software architecture?
Okay, think of the main AI model as the bartender at an exclusive club. The bartender's job is to mix drinks and talk to the patrons.
Okay, I like this analogy.
But you don't just let anyone walk off the street and start yelling at the bartender. You have a bouncer at the door.
The bouncer.
One of the most critical guardrails is a relevance classifier. This is essentially a secondary, much smaller, much faster AI model whose only job is to act as the bouncer.
So it screens people.
It stands in front of the main model, it reads the user's prompt, and it just asks one binary question. Is this input relevant to our business?
Let's use an example. Imagine you build a customer service bot for an e-commerce clothing store.
Sure.
A user logs on, opens the chat window, and types, "What is the architectural history of the Empire State Building?"
The bot shouldn't answer that. It has absolutely nothing to do with selling shirts.
But a basic language model wants to be helpful. It is trained to answer questions.
Right?
So if that prompt hits the main model, It will happily generate a beautiful 3-paragraph essay on the Empire State Building.
Which wastes compute cost and opens the door for prompt injection attacks.
Exactly. But with a layered defense, the bouncer, the relevance classifier, catches that input first. It flags it as off-topic, blocks it from ever reaching the main bartender, and forces the system to reply with a hard-coded message.
Like, I'm a customer support assistant for this clothing brand. I cannot answer queries outside of our products. How can I help you with your order?
Yes, it forcibly keeps the AI in its lane.
That makes so much sense. And what other bouncers are at the door?
You also layer in PII filters. PII stands for Personally Identifiable Information. If a customer types their social security number or their full credit card number into the chat, the PII filter acts like a digital redaction marker.
Oh, that's smart.
It scrubs those numbers out and replaces them with asterisks before the prompt is sent to the AI. That way the AI never even sees the sensitive data, so it can't accidentally memorize it or store it.
Wow.
You also use moderation APIs to instantly detect and block hate speech, self-harm language, or abuse.
Let me pause you there because you just touched on the exact thing that holds so many people back from using AI at work. Data privacy.
Oh yeah, data privacy is a huge roadblock.
It is the #1 fear I hear. People say, if I upload my company's Q3 financial spreadsheet into this AI to do data analysis, is OpenAI or Google going to use my internal revenue data to train their next model?
Right.
Will my competitors be able to ask the AI for my secret numbers tomorrow?
The short, definitive answer for enterprise AI is no.
But how do we know that? People are highly skeptical.
We know it because of enterprise compliance standards. When you are using true enterprise-grade tools like an enterprise tier of Copilot or ChatGPT Enterprise or Gemini for Google Workspace, your data is governed by strict, legally binding compliance frameworks like SOC2 Type 2.
What does SOC2 Type 2 actually mean, like practically?
It is an auditing procedure that ensures a service provider securely manages your data to protect the interests of your organization and the privacy of its clients.
Okay.
In the context of AI APIs, it means they utilize zero data retention policies. The bedrock principle is that enterprise data is never ever used to train or improve the provider's base foundational models.
Never, ever.
Never. Your data is encrypted in transit and at rest. It is completely siloed. It remains entirely under your control, and when you delete it, it is gone.
Okay, that covers the fear of OpenAI stealing my data. But let me push back with a different fear, internal data leakage.
Oh, internal leakage. That's a good one.
What if my company builds an internal AI agent that has access to all our files? If I, a junior employee, log on and ask the internal bot, what is the CEO's exact salary and bonus package?
Yeah.
What stops the AI from going into the HR folder, finding the spreadsheet, and just telling me?
That is a brilliant question, and it is a massive concern for IT departments. The answer lies in how these internal systems are built, specifically using a technique called RAG.
RAG!
RAG Retrieval Augmented Generation.
Okay, ELI 5 time. Explain RAG to me like I'm 5.
Imagine taking an open book test. The AI is the student taking the test, but the AI is not allowed to just wander into the massive company library and read whatever it wants.
Yeah.
It has to ask the librarian, the Argyre system, for the books.
Okay, the librarian is the gatekeeper.
Exactly.
Yeah.
When you, the junior employee, ask a question, the librarian first checks your personal security credentials. It checks your permission slip. It says, does this specific user have access to the HR folder? If the answer is no, the librarian does not retrieve the document. The AI never even sees the document, so it physically cannot answer your question about the CEO's salary. It will just say, I'm sorry, I don't have information on that.
So the AI inherits my exact security permissions. It can only read what I am allowed to read.
Exactly. The AI does not bypass your existing access controls. It strictly adheres to them.
Okay, that is a huge relief. But there's one final safety question. Even with evils and bouncers and PII filters and RAG, what happens when the AI is just genuinely confused?
Like when it gets stuck.
Yeah, what happens when a customer has a deeply complex, nuanced issue that doesn't fit into any pre-programmed flow and the AI simply cannot resolve it? Are we just dooming our customers to be trapped in an automated phone tree nightmare forever?
This is perhaps the most crucial philosophical point in all the documents we reviewed. Across every single source, Google, OpenAI, and McKinsey, they all stress the absolute necessity of the human in the loop.
The human in the loop.
The golden rule of enterprise AI is that the final output, the final high-stakes decision, is always the human's responsibility. AI is an assistant and accelerator. It is not a replacement for human accountability.
So how does that work technically with an autonomous agent? How does an agent know when to give up?
You build in strict failure thresholds and human escalation protocols.
Okay.
Let's say your agent is authorized to handle customer returns. You program the behavioral logic so that if a customer asks for a refund over $500, that is automatically flagged as a high-risk action.
So the AI stops.
The agent pauses, gracefully tells the customer, "I understand you need a refund for this large order. Let me transfer you to a senior specialist to finalize this immediately," and it hands the entire context of the chat over to a human worker.
Oh, that's elegant.
Or, if the agent loops 3 times trying to find an answer in the database and fails, it triggers an automatic handoff. The AI must be programmed with the humility to know its own limits.
It must know when to surrender. That makes complete sense. Okay, we have covered a staggering amount of ground.
We really have.
We've talked about the shift from reactive chatbots to proactive agents. We broke down the mechanics of the 21-word prompt and the 4 pillars. We explored the anti-to-do list, the 6 primitives, and how non-coders are using sandboxes to do data analysis.
And we just thoroughly covered how to build these systems safely with evils, guardrails, and R.
Which brings us to lesson 5, our final major theme. Once you have safety and trust established, how do you move from saving a few hours a week as an individual to fundamentally transforming the bottom line of an entire enterprise?
Scaling from isolated quick wins to enterprise magic.
Yes, and again, the numbers and the sources are almost hard to believe until you understand the mechanics. Let's look at Klarna, the massive global payments network.
Oh, the Klarna case study is incredible.
They implemented an AI assistant for their customer service operations. The result: they reduced their average customer service resolution time from 11 minutes to just 2 minutes.
A nearly 6-fold increase in speed.
And it handled 2/3 of all their customer service chats. It did the equivalent work of 700 full-time human agents, all while maintaining the exact same customer satisfaction scores.
And what was the financial impact?
The projected financial impact for Klarna: a $40 million improvement in profit over the year. $40 million.
But what is critical to understand about Klarna isn't just the cost savings, it's the operational shift. What happens to those human agents when the AI handles 2/3 of the volume?
They get fired.
No, they aren't just sitting there, and they aren't necessarily let go. They are now freed up to handle the most complex, high-tier emotional escalations.
Oh, I see.
They are handling the 1/3 of cases that require true human empathy and complex problem-solving. It elevates the role of the human.
And then look at BBVA, the global banking leader. They took a slightly different approach to scaling. Instead of just building one massive top-down customer service bot, they empowered their employees.
They rolled out secure enterprise AI tools and essentially let their teams discover their own use cases.
They decentralized the innovation.
Exactly. And what happened? In just 5 months, BBVA employees built over 2,900 custom GPTs.
2,900 distinct targeted AI tools. Legal teams built bots to quickly answer and on the horizontal axis, you have effort. How hard technically and organizationally is it to build this automation?
So you have 4 quadrants: high impact, high effort, low effort, low impact, high effort, and low impact, low effort.
Exactly. And the absolute secret to successfully scaling AI in an organization is to ruthlessly, obsessively target the quick wins quadrant. High impact, low effort.
Give me an example of what not to do.
Do not start by trying to build an autonomous agent that dynamically manages your entire global supply chain inventory based on real-time weather data.
Right. That is incredibly high impact, yes, but it is overwhelmingly high effort.
It requires massive data integration, intense security reviews, and huge behavioral changes. It will take you 8 months to build. You will get bogged down in technical debt. Stakeholders will lose patience, and the company will declare AI is a failure.
So instead of the global supply chain, you start with the anti-to-do list.
Yes. You find a task that frustrates your team every single week. For example, taking the messy transcripts from 5 different weekly client calls, extracting the action items, formatting them into a specific table, and emailing them to the department.
That task might take a human 2 hours every Friday.
Hmm.
But using the content creation primitive, it is incredibly low effort to build. You can build a custom prompt or a small script to automate that in an afternoon.
Suddenly, you have a quick win. You just permanently save 2 hours a week. You show your boss shows the department head, you prove value immediately, and you build organizational momentum.
And that momentum leads to what the blueprints call the compounding effect.
This is a vital philosophy to understand, and it represents a massive psychological shift for the worker. AI is not traditional plug-and-play software.
Well, you buy a traditional software license like a new word processor, you turn it on, you learn where the buttons are, and it does what it does. Its utility is static.
But AI is a completely new paradigm. It is probabilistic. It requires an experimental mindset. The earlier you start playing with it, the earlier you start building those small, quick wins, the more your intuitive knowledge of how the model thinks compounds.
Klarna didn't just wake up and generate $40 million in profit on day one.
No, they started small. They learned how the models behaved. They learned the nuances of prompting. They learned how to build robust evils and set up guardrails. And they compounded that institutional knowledge over months of relentless iteration.
Let's talk about the psychological shift for the employee here,
Mm.
because compounding these wins fundamentally changes what your job actually is.
It does. It moves you from being a doer of tasks to a manager of digital systems. And there is a real psychological friction there.
Many people secretly like busy work.
Okay.
Formatting that spreadsheet on a Friday afternoon is tedious, yes, but it's also safe. It feels productive without requiring deep, vulnerable, creative thought.
When AI automates away all your busy work, you are suddenly forced to stare at the truly hard strategic problems. It is a terrifying but incredibly liberating shift.
So what does this all mean for you, the listener? Let's bring this entire deep dive all the way back to that scenario we painted at the very beginning.
You are sitting at your desk, it's Friday afternoon, you have that mountain of open tabs, the meeting notes, the unwieldy spreadsheet, and the looming deadline.
It means you do not need a massive corporate tech budget, and you do not need a computer science degree to solve that problem today. You just need to systematically string together those small primitives we talked about.
Right. You don't try to build one giant magical brain to do everything at once. You build an assembly line of quick wins. Think about how this looks in practice.
Walk me through it.
First, you use the research primitive. You tell the AI, go read these 3 specific competitor websites and extract their pricing models into a list. Boom. The research phase is done in seconds.
Then, you hand that extracted list directly to the data analysis primitive. You upload your messy spreadsheet into the secure sandbox and you say, take this new pricing data, compare it to our historical spreadsheet, fix the broken date formats and create a clean table highlighting exactly where we are more expensive.
The AI writes the code, runs it, and the analysis is done.
Finally, you hand that clean table to the content creation primitive. You use your 21-word prompt, hitting the 4 pillars. Act as a strategic product manager. Take this data table and draft a 3-paragraph executive summary for the CEO comparing our pricing. Format it with bullet points.
The draft is generated instantly. You just automated an entire afternoon of grueling multi-step cognitive labor by simply stringing together 3 basic primitives.
And suddenly, it's 4:00 p.m. on Friday. Your work is done.
Yeah.
It is highly accurate because you stayed in the loop and verified the logic. And you could log off for the weekend.
That is the true power of compounding quick wins into enterprise magic.
It is truly a modern superpower.
Okay, we have covered a massive amount of incredibly dense material today. We went from defining the anatomy of autonomous agents and how they use APIs to the psychology of the 21-word prompt versus the 10-page agent manual.
We explored the anti-to-do list, the 6 primitives, and how sandboxes allow anyone to code. We broke down the rigorous safety mechanisms of evils, guardrails, and RAG. And finally, we looked at scaling through the impact effort framework.
It is a comprehensive, actionable blueprint for surviving and thriving as a modern knowledge worker.
But at Cortex Lab, we don't just want you to passively listen to this information. We want you to actually take action.
So here's the one clear, actionable takeaway we promised you. Today, right now, before you log off or close your laptop, I want you to write down your own anti-to-do lists.
Get a physical piece of paper. Write down 3 specific, annoying, repetitive, low-value tasks that you absolutely dread doing every single week. Be specific.
Then, map those 3 tasks onto the impact effort framework. Find the task that takes up the most time but seems the easiest to explain to a human intern. That task is your quick win.
And this week, I want you to tackle automating just that one task using AI. Use the 4 pillars persona, task, context, format, and make sure you use a clear action verb.
Reclaim those hours. Prove to yourself that the technology works.
And always remember, you are the human in the loop. Review the work. Verify the logic. Build your own trust with the tool.
As we wrap up this Cortex Lab deep dive, I want to leave you with one final, slightly provocative thought to mull over as you go about your week.
Ooh, what is it?
We spend all this time, energy, and money figuring out how to get AI to do our repetitive work for us. But think deeply about this. If AI successfully automates your entire anti-to-do list, if it seamlessly writes all your emails, formats all your spreadsheets, conducts your data analysis, and executes all your deep research, what is left?
Wow. Yeah, what is left?
What are the uniquely human skills like radical empathy, complex relationship building, ethical judgment, or truly lateral creative strategy that will suddenly become the absolute most valuable currency in your career?
When the rote robotic work disappears entirely, the fundamentally human element becomes the ultimate premium product.
Exactly. Thank you so much for joining us on this deep dive. Stay curious, start experimenting, and we will see you next time. This deep dive was brought to you by Cortex Lab.